Welcome back, grade 10. So now we are continuing with our videos. So the first video or the previous video that we did on analytical geometry, we said that we are giving you now the foundation for the next video, which is the functions. So in this topic or in this video, we are going to look at the linear function or the straight line graph. Remember, in this topic, there are four graphs or four functions that you are going to look at. The first one is a linear function. The second one is a quadratic function. The third one is a hyperbolic function. The fourth one will be the exponential function. So these are the graphs that we are going to look at. But in this video, we'll just look at the linear function or the straight line graph. Then the next one, we'll do the quadratic. The third one will do the hyperbolic. The fourth video will be on the exponential. So let's quickly look now at the linear function. So the linear function has this formula that we said it's y is equals to mx plus c, or sometimes they put it as y is equals to ax plus q. So this now is the function of the straight line graph. Sometimes instead of putting y, they can put the x function like that. They can say f of x is equals to mx plus q or mx plus c. Yeah, so this is the function of a straight line graph. Now let's interpret all these variables that you see here. The first one is y. Now this y is the point where the graph will cut the y-axis. So I'll just say it's the point where the graph will cut the y-axis. So on your graph, I'll give you an example. For example, you have this graph here. So this graph, as you can see, that it cuts this at the y-axis. So it cuts the y-axis at this point. So this point now is a point where the graph cuts the y-axis. It is represented by this y. Now the x that you see here next to the m, that x now is the point on the graph, is the point where the graph cuts the x-axis. For example, if you look at this graph, there is a point here which is in this case is a negative x point. So this point now is a point where this graph cuts the x-axis. On the other side, this graph cuts this point, which is the positive x. This graph cuts this point, which is a positive y. So these 2 points now are represented by this y and x. These are the points where the graph cuts the y-axis and the x-axis. Now, if you look at the m, on the previous video, we said this small letter m represents the gradient. So this is the gradient or the slope of the graph. Now the gradient can be positive and negative. For example, this one, the gradient is positive, which means that if your graph is from the first quadrant to the third quadrant, we can say now this graph is in the first and the third. So if your graph looks like this, that gradient will be a positive gradient. But if you look at the second graph, this graph now is on the second quadrant and the fourth quadrant. So if your graph now is pointing at the second quadrant and pointing at the fourth quadrant, that gradient is going to be negative. This one is positive. So the gradient can be positive or negative. If the slope is like this, that gradient is positive. If the slope is like that, that gradient is negative. That is what is represented by the m, or sometimes the a. So the a and the m represents the same thing. A is also a slope or a gradient. Now the c that you see here, or a q, they both also represent the same thing. C and the q, this is the point where the graph cuts the y-axis. It's the same point. So you can say this is the y-intercept. So it's the same thing as a point where the graph cuts the y-axis. Now let us look at the two concepts which we call the domain and the range. The domain and the range. Oh, before we do that, so if you look at this equation, if your slope is positive, then that means your equation is going to be y equals to positive mx plus c. Let me give you an example. If I said y is equals to 2x plus 3, you can see that this is a positive gradient. That means your graph will start from the first quadrant to the third quadrant. But if I give you an equation and said y is equals to negative 2x plus 3, so that means now the gradient is negative, so my graph now is going to start from the second quadrant to the fourth quadrant. That's why the equation looks like this. If you see the m is negative, then you know the graph is going to be from second to the fourth. If you can say positive m, you know your graph is supposed to be from the first to the third quadrant. So that's what you need to be aware of. Yeah, now there is a concept of the domain and the range. The concept of the domain and the range. Don't forget your formula for the gradient is always the gradient equals to y2 minus y1 over x2 minus x1. We did this one from the previous video, so I'm not going to go any further for the gradient, explaining the gradient. I'm just going to explain the domain and the range, then we do a few examples on the straight line graph. Okay, a domain, if you look at this concept of a domain, they said that now the domain are all the possible x values and they must be real numbers. If you look at the range now are all the possible y values and they must all be real numbers. In other words, the domain is like an input to your function and the range is like an output to your function. Let me give you an example. Let's say that you are given the equation y is equals to 2x plus 4. Let's say 2x plus 4. So let's quickly draw the graph of y is equal to 2x plus 4. So to be able to draw this graph, you need to find the y-intercept. So to find the y-intercept, you need to make x equals to 0. So if you make x equals to 0, then y is going to be equals to a 4. Now you need also to find the second point, which is the x intercepts. So the function is y is equal to 2x plus 4. So let's make now y equals to 0 to find the values of x. So I'm going to make y equal to 0. Let's take the 4 to the other side. It's going to be negative. So we divide by 2. We divide by 2. So the x values now is negative 2 because negative 4 divided by 2, that's negative 2. Okay, so I have to plot now these 2 points. Now the y intercept is 4. So let's say here is 4. Then the x-intercept is negative 2. Let's say here is negative 2. Now you have to now join these 2 points. So I'll just draw a line. Oh, my line is not cutting through. So it has to cut from 4 and 2. Okay, I don't have a straight line here. Okay, this is the straight line, but you can see what I'm trying to do. So it's cutting at 4 and cutting at negative 2. Now remember, the graph now must always be represented with these arrows. If you look at this arrow, it means that this graph is continuing. Now it's continuing, it's going up all the way up to infinity. And also if you look at the other point down here, there's an arrow again. That arrow means this graph is still going down. So it's going down to infinity. We said it's going down to infinity. Infinity means unending. It's going now forever. It's going up without ending. It's going down without ending. So now the domain of this graph will be, we can represent it like this. You can say it's going now from negative infinity. Infinity has a symbol that looks like this. So it's from negative infinity. It's like an 8 that is written upside down. And also to the positive side, it's like 8 that is written upside down. And also your range, if you look at your range is also, because of it's still going further, still going up without ending. So it's going now from negative infinity up to positive infinity. So it's like an 8 that is written upside down. Yeah. Otherwise, this is a domain, this is a range. That means all the values, -2, -3, -4, -5, -6, is going forever to infinity. Also, from the positive side, all these values here that the values of x is going forever. All the y values up there is going up there forever, and all the negative values down there forever. So this is a domain and that is a range. That means any value starting from -2 moving this way and -2 moving that way. Yeah, so that's a domain and a range. So let's now look at the few examples, let's say 2 examples of how to plot a graph and how to answer the question on linear function. Okay, let's look at this example. So we'll say this is example number 1. So in this example, the question is saying determine the equation of a straight line. So we want to find the equation of a straight line passing through the point A and B. So we want to know now how to find the equation of a straight line. Remember, the standard form for the equation of a straight line is y is equals to, you can say ax plus q, or you can say y is equals to mx plus c. In other words, we need to find y, we need to find m, we need to find x, we need to find c. So we are going to now show you how to find the equation of a straight line. We're going to use this formula, y is equals to mx plus c. So let's use that one, or if you like, you can use the other one, y is equal to ax plus q. So this is now how we're going to do it. The first thing that we have to find, we need to find first the gradient, the m. So we always start finding the gradient. What is the formula of a gradient? Gradient, we said it's y2 minus y1 over x2 minus x1. So I'm going to take now a as my x1, and this will be my y1. This will be my x2, this one will be my y2. So I'm looking at a and b. This is a gradient of a and b. So the gradient between the point A and B is y2. What is y2? y2 is this y value of b, which is a -2, minus y1, which is 3, which is the y value of a, all over x2 will be 3 from b, then x1, okay, my pen does not want to write now. What's going on here? Okay, yeah. So the x2 will be a 3 from a b, minus the x1 will be a -4 from the a. -2 minus 3, that's going to give you -5. Now here we have 3 negative times a negative, that's going to be a positive. So we have -5 over 7. So -5 over 7 will be my gradient. So we did find the m, which is -5 over 7. You also know how to do this one from the previous video. So I'm going to say here, okay, I have now something like y is equals to -5 over 7 x plus c. So I substitute now the m because I know the m is -5 over 7. Now I need to find the point y and x. Remember, this point y and x, you can choose, you can take, for example, this point A, which is -4 and the 3. You can use this point. This is your x, this is your y. So we can take now this 3 to be our y value, we can take this negative 4 to be our x value. If you like, you can also take b. The answer would be the same. The equation will be the same. So I will take point A, for example. Where I see y, I'm going to put a 3 equals to negative 5 over 7. Where I see x, I'm going to put this negative 4. Now the only unknown now will be c. So now that means that I need to find c, because of c is the only one that is unknown. So let me calculate c. So I have 3. Negative 5 times negative 4, that's going to be positive 20 over 7 plus c. Now if I want c now, I have to take this 20 over 7 to the other side. It's going to be negative 20 over 7. Remember, this 3 is over 1. So I want to find now my c coordinate. Okay, I need to find a calculator to quickly do this one. So I have a fraction which is 3. I have a fraction which is 3 over 1. So that is 3. Okay, my calculator is freezing here. Okay, let me quickly fix this one. So we have a fraction here. Yeah, here is it. So we have 3 over 1 minus 20 over 7. You can see the answer is 1 over 7. So that means the c coordinate is 1 over 7. So I have the m, I have the c. Now I can say my equation is y is equals to the gradient, which is negative 5 over 7x plus 1 over 7. Because if I do have now the gradient and I do have the c, which is a y-intercept. So this is the equation of the line. If you like, you can also put b here, where you see this is the coordinate of b, which is 3 and negative 2. So this is a x, this is a y. So you can say y is equals to negative 5 over 7x plus c. So where I see y, I'm going to put the negative 2. Where I see x, I'm going to put the 3. Let's check now what we are going to get if we use the b point. Negative 5 over 7. Where I see x, I'm going to put the 3 plus c. So let's calculate now. Negative 5 times 3, that's negative 15 over 7 plus c. So I want to find c. So I take now this negative 15 over 7 to the other side. It's going to be positive 15 over 7. Remember, this 2 is over 1. So let's punch this now on the calculator. Yeah, so if you punch this on the calculator, negative 2 over 1 plus 15 over 7 will also give you 1 over 7. So the answer is still the same. It's 1 over 7. So you can see that the equation is still the same, negative 5 over 7x plus 1 over 7. So even if you take point B or point A, the answer will be the same. So this is the equation of a line that we are required to calculate for example number 1. Okay, now for example number 2, let's look at this one. So you are given a statement here that says determine the equation of a straight line passing through this point, negative 1 and negative 1, and perpendicular to x minus 4y is equals to a 4. So they said, let us find the equation. We need to find the equation of a line. And this line is passing through this point, which is negative 1 and negative 1. And this straight line is perpendicular to this line, x minus 4y is equals to a 4. So we need to find that straight line. I'll be using now this information that it gave us. So the first thing that we have to do now, we have to find first the gradient of this line. We can find the gradient of this line because they told us that this line, the equation of this line is perpendicular to this equation. Okay, I'm going to call this equation that we are required to find f of x. Then I'm going to call this equation that we are given here g of x. Because of this, there are two lines. There's a line that we are required to find, then there's a line that we are already given. So if you have time, you can draw the equation of the graph that you are given, the straight line graph that you are given here. Okay, so this is the Cartesian plane. So I want to plot now the equation of g of x. This equation, the second one. But before we do so, let us put this first in a what do you call it, in a standard form. So I have x minus 4y is equals to a 4. So I have to have y on the left and everything else must be on the right. So let me leave this negative 4y is equal to 4. Let me take that x to the right. So it's going to be negative x. But the best way, let's put it this way. Let's start with the x. Yeah. So I'm going to say I have x to the right is going to be a negative x, and then I'm going to leave this 4. Now I want to get rid of this negative 4 to have only y on the left, so I have to divide now by negative 4, divide everything by negative 4, divide everything by negative 4. So now I have y on the left is equals to, here I have negative 1. Remember there is a 1 here that is invisible. So negative 1 divided by negative 4 is just 1 over 4. Negative and negative just cancels. So I have negative 1 over 4 x. Here I have negative 4 divided by, positive 4 divided by negative 4. That's going to give me a negative 1. So this is now the equation of this line that I called g of x. So its y is equals to 1 over 4 x minus 1. So this is the equation. I want to plot now this graph. Remember we said if you want to plot the graph, we must first find the y-intercept. How to find the y-intercept? Make x 0. So make x 0 minus 1. So y is equals to negative 1. So that means the first point I'm going to have is the negative 1. This is y. Remember, these are your y-axis. This is a negative y-axis. This side is a positive x-axis. That side is a negative x-axis. Yeah. So now let us find the x-coordinate. You know how to find the x-intercept. We must make now y to be 0. So I'm going to say now y is 0. I'm looking now for x. So I'm going to now take this negative 1 to the left. So I have 1 over 4 x is equals to a 1. So if I'm looking now for this x, I have to either divide by 1 over 4 on the left, divide by 1 over 4 on the right. So I'm going to have x is equals to 4. Now, don't have space here to do that, but you can say 1 divided by 1 over 4, you're going to get 4. So that means this is 4. The positive x value is 4. So I have to now plot now this graph, this straight line graph, and see how it's going to look like. Remember, my gradient is positive 1 over 4. That's why it's going to start from the first quadrant to the third quadrant. Yeah, so this is how your graph will look like. So this is the graph of this line g of x. So it's going to look like this. Is a positive line with a positive gradient. Now, they said now determine the equation of a straight line passing through negative 1 and 1. Where is negative 1 and 1? So the x coordinate is negative 1 and the y coordinate, they said it must be negative 1. So I want to show you this point. So this point, the x coordinate is negative 1 and the y coordinate is negative 1. So this is the x coordinate that is negative 1. This is the y coordinate that is negative 1. So they said now this line that we have to draw is passing through this point. This is the point. So this is the x, this is the y. So this is the point that is passing through, but I wanted to show you. So it's passing through this point, and this line is perpendicular to this g of x. So I'm going to draw you now this line, try to give you a picture how it looks like. Yeah, so this line looks something like this. So yeah, this is the x-axis. Yeah, so this line is perpendicular. This is the perpendicular line. It is perpendicular now to this g of x. So I'm going to call this line now the f of x. So we want to find the equation of this line, and it's passing at this point. This is the point -1 and -1. This is that point. It is passing through this point, but it is also perpendicular to the line g of x. So we want to find now the equation of this line. So the only thing that we know about this line is this point. Let's call this point point A, for example. So let's say this line is passing through point A, perpendicular to g of x. Let's first find the gradient of this line. Now, how are we going to be able to find the gradient of this line if we don't have 2 points on this line? Then we have to use now that formula that says we can know the gradient of f of x by multiplying it with the gradient of g of x equals to -1. This is a formula. If you multiply the gradient of the two, they will give you -1. But we don't know this gradient. We do know this gradient, and we do have a -1 on the other side. So let's find now this gradient. So the gradient of the line f of x multiplied by the gradient of the line g of x. Sorry, why did I say g of f there? This is g of x. So this is the line g of x. So we do know the gradient of the line g of x. We said it is 1/4. So that gradient is 1/4 equals to -1. So let's find now the gradient of the line f of x. So we're going to say -1. If we divide this side by positive 1/4, we have to divide also that other side by positive 1/4. So the gradient now of the line f of x is going to be equals to -4. 1 divided by 1/4 is going to be equal to -4. So the gradient of this line is -4. So let's find now the equation of this f of x. We do know now the gradient. The point A, remember we said we do know the point A. Point A is -1 and -1. So I'm going to substitute this point now for my y and my x. So for the y, I'm going to put -1 because y is -1 equals to the gradient is -4. The x coordinate is also -1. Now I have to find the point C. So what is -4 times -1? That's a 4. Now take 4 to the other side, so you have -1, -4. So C is equals to -5. Now we do have C is -5. So now let's go back now and say the equation of this line is y is equals to the gradient, which is -4, and the C coordinate, which is -5. So this now becomes the equation of a line f of x. Y is equals to -4x minus 5. The equation of g of x, we said it is y is equals to 1/4x minus 1. So that is how we find the equation of that line that is passing through point A, perpendicular to g of x. Yeah, so it was like a little bit tricky because of they didn't give you 2 points for this f of x line. They only gave you 1 point. So if you know the gradient of the line that is perpendicular with, so you can use this formula every time. This is the formula to find the gradient of either f of x or g of x if you are given one of them. Yeah, so this was the end of example 2. You can pause the video and try to go through your calculations and see if you are following. So now I think this is the end of our, okay, you know, there's one more example where we are required to draw a straight line. So let me do that one more example, then we'll end this video, then we'll do the second video, which will be a graph of the quadratic equation. Let's do the third example. Okay, so this is the third example. We'll quickly do this one. Example number 3, sketch the following graphs on the same set of axes. Show all intercepts with the axes. So the first graph is this one. F of x is equals to negative 2x plus 1. Then the second graph is y is equals to negative 3. Yeah, so we'll do now these two graphs on the same set of axes. Okay, so let's start with the first one, the f of x. They said f of x is equal to negative 2x plus 1. So you know that you have to first find the y value. So you have to make x 0. So the y value will be 1. Then you have to find now the x value. So you have to make now y 0. So to find x, you have to take the 1 to the other side. So it's going to be called negative 1. You have to divide by negative 2 on both sides. So x is equals to 1 over 2. So we do have the y, we do have the x. Let's plot that one. Y is 1. Let's say here is 1. X is a half and it's positive. Let's say here is positive a half. So we need now to join these 2 points to draw the graph of f of x. Okay, so let's say this is the graph of f of x. We have to just join these 2 lines. Now, let's draw the graph of y is equals to negative 3. So this is just a graph of y is equal to negative 3. Let's say this is negative 3 on the y negative axis. So just draw a straight line now passing through negative 3. Yeah, so this is how the graph will look like. So I'll call this one g of x. For example, let's say this one is g of x. Yeah, so these are your 2 graphs, a graph of f of x and graph of y of, g of x. Yeah, so this is the end of our video for the linear function or the straight line graphs. So now we are going to the second video, which will be the quadratic function or the quadratic graphs.